It is fall, definitely stick season here in Saskatchewan. The trees are just about bare. We've had a few little bits of snow, but nothing that's stuck around yet. And we're getting into the routine of fall and the semester. You run into old friends and you want to catch up. Hey, how are you doing? How's your year going? How was your summer? What did you do this summer is the question we're asking 3 students over the next 3 episodes. And that's because research doesn't always go quite according to plan. Sometimes things get a bit weird or wacky. With curiosity and with persistence, that's usually where you uncover some of the best parts of science. Our first guest in the series is Eve Simpson. She is a biomedical science undergrad working towards her honors project, and she's been looking at Eastern Equine Encephalitis Virus, EEEV, sleeping sickness.
It's not always a death sentence, but when it does get to your brain, it unfortunately pretty much is. So what I can see this research going is hopefully trying to find some answers so that one day we can have a vaccine or an antiviral, because to get there, somebody needs to do the work to understand the pathogen.
Eve Simpson is our guest today on Researchers Under the Scope. It is November 2025, and we recorded this interview on the 4th floor of the Health Sciences Building at the University of Saskatchewan's College of Medicine. I'm your host, Jen Cannell, and this is Researchers Under the Scope. Our guest today is Eve Simpson. She's in her 4th year, working towards that honors thesis in biochemistry, microbiology, and immunology. She was an award winner at the 2025 Undergrad Research Showcase Awards last month, and that's when I caught up with her. Hello, Eve. Welcome to Researchers Under the Scope.
Hi, Jen. Thanks so much for having me.
How did the awards go?
Unexpected. Honestly, I was listening to everybody else's presentations and I was just like, wow, mine was not nearly as good. But I guess fortunately they thought it was pretty decent, and I did get 2nd place, which was a very big surprise. But honestly, I'm just proud of everyone that did present.
Well, and it's behind you now.
Yeah.
That part's done.
Exactly.
But I mean, what's the best way of describing what you looked at?
I was looking at some kind of viral interaction between NSP1 of EEV and the VATPase complex in humans. So I know that sounds like kind of a mouthful. What is all of that? So I like to think of it as cells are like a city, and every single organelle has its own job. And then we have these things called vesicles. They're like these bubble-like structures, and I kind of think of them as like delivery trucks almost. Okay. So they're delivering the waste, nutrients, proteins. They have so many jobs, and viruses like to take advantage of them. They can come into the cell using these vesicles, and it helps them lead to infection. And we also use these vesicles for, in an infectious manner, they present these peptides and proteins on the surface of the cells. So in these vesicles, we get these things called MHC complexes, and on those get loaded these proteins and these antigen peptides, and those go up to the surface of the cell. And these tell the immune system, they're like, hello, we need help, we're infected. Like it's like a signal of there's an infection going on. These are really important for getting an immune response. So viruses, some of them like to block this process. So
right.
then,
cut the phone so you can't call
yeah,
911.
you can't alert the immune system. So within these vesicles, we have these really important structures called VATPases, which I was looking at. And these are proton pumps. So they pump in hydrogens into the vesicles and they acidify them. This acidity is really important for different processes like degrading the proteins, and proteins are just really, really specific to different pHs. So just this acidity really helps for all of these different functions that these vesicles do. We had preliminary evidence that NSP1, which is a viral protein in EEEV, actually interacts with these VATPase complexes. Yeah, so our goal was to look at is this interaction actually happening? And why? Like, why does the virus want to touch this VATPase? So we're not sure what it's doing yet, but we know that obviously it must be helping the virus in some way. If it's interacting, it's got to be helping it. So we were trying to look at, why is this happening? What's the biological impacts of it?
So the number one was, is this happening?
Yeah.
And number two, if it is, why? What is the impact of this and why are they doing this?
Exactly, yeah.
Can you take me back a little bit to how you even landed in this lab?
Yeah, for sure. So it's a little bit of not a straightforward path at all. I always knew, like, even from high school, I was like, I'm gonna do research. Like, I know this is what I want to do in life. So second year, I applied to Dr. Napper's lab. I picked one of the biggest labs for some reason, very, very optimistic, and I didn't get it. He did say I was a great candidate though. I still think about that, but I didn't get it and I was crushed. I thought, wow, maybe I'm not good enough to even get a science job. And so that kind of put me off and I didn't apply to any more labs that year. But then my history professor, I was in a history class, and he reached out to me and was like, do you want a job? So I was like, sure.
I need a job, yes.
Yeah, why not? So I was working in his lab on extraditions and such as like murder cases all the way from the 1800s. And so completely not science related, but he was such a good supervisor, Dr. Benjamin Hoy on campus. And he knew that I wanted to get into science. So he's like, let's set you up in the best way possible. And so he had me working on like data entry and taking initiative in projects, skills that would be transferable to the science field. So, and he gave me this piece of advice, which I really stuck to, and it was, make people say no to you.
Oh.
Yes.
So have the guts to put yourself out there and give them what you've got, and then they have to say no to you.
Exactly. Ideally, yes. But, you know.
Ideally, it's a yes.
Yes, yeah. But to put yourself in that position to have somebody say no, which is really scary because I'd already kind of felt like I failed at getting that. But I thought, you know what, let's try again. And so that's when I reached out to Anil, and it was just, it was, yeah, a good experience. He said yes, and it was definitely a confidence booster. I was like, okay, maybe I'm not so bad at this.
So how did you go about doing the work in the lab?
So I looked at, we use this thing called immunoprecipitation. I put the pieces of DNA that I want that express the specific proteins, and I put them in the cells express them for me, and then I harvest the proteins from the cells, and then we use these magnetic beads which bind the specific protein, so like the NSP protein, and then brings it down, and then I can kind of like collects it. So I just have this like tube of this NSP1 protein, and then I run it on a gel, and I see, was this ATP6V1B2? That's one of the subunits of the VATPase complex. And I'm looking to see, did this also come down? Because if it's interacting with the NSP1, then when I bring it down, it'll bring the B2 down as well. So that's how we're trying to look, like, are these two together?
That's the proof.
Yes, that is the proof, which we're still working on getting. Because, of course, science is weird. And we try to use these controls. One of the other NSP proteins, NSP3, we didn't have evidence that those two interacted. So I used it as a control, because if I know those two don't interact, then the results will look different for those two.
Right. It will consistently not have that interaction, yes, and you can trust it.
Yeah. However, that wasn't the case. I actually saw that those two were also interacting. So I'm like, okay, I need another control. And then my newest results are showing that my newest control, there is an interaction, but now there's no longer one between the NSP1 and B2. So it's just completely contradicted itself.
So, and as you were getting these results back in the lab, what is going through your mind at this point, Eve?
At this point, do I just suck at science? Yeah. Maybe this isn't what I'm cut out for. And it was really hard, because I was, what if I've spent my time doing this degree and I'm actually just not cut out for science, and now I have no idea where I want to be in life. And That's actually a surprisingly common thought that we have all in science, because I talked to many people. I got many pep talks. I'm very lucky. The lab and everyone on that research floor have all gone through the same things, still go through the same things, and give good pep talks that, science is about questioning and trying to find things. And if you find all the answers right away, or you think you find all the answers, you're probably wrong and looking in the wrong place.
Yeah, you found all the answers in this one drawer, but that's not the extent of the drawers or the problem.
Exactly.
Oh, how did you get past it?
It was hard, and I felt I was letting everyone down because they're all putting this time and effort to train me, and I'm just not doing good. That's how I felt. And fortunately, I guess it's not great that other people feel like this, but it is comforting to know that it's actually a really common feeling in science. Everybody that I spoke to, the many pep talks that I got, everyone said the same thing, that they've been through that. It's part of being a researcher, and that's what drives us to do better and keep being curious and learning, because we don't know everything. But you do still have to give yourself some grace and recognize that you are learning, and that you can be an expert in your field, but still have something to learn from somebody else. So at the beginning, I didn't get through it. I was sad. I definitely cried to my boyfriend a lot, not gonna lie, and was just not very confident. And it took some more failures, honestly, to just realize that it's a part of science, and that either I can get over it and do what I love, or I can let it stop me. And as my boyfriend always tells me, he has never seen me quit. I'm annoyingly perseverant. So I decided, okay, I just got to get over this hump. If I truly want to make a difference and do what I love, then I need to get over it. And fortunately, I had the help of all the support of everyone in the lab and everyone on that floor, who were telling me that I'm doing a great job and that the successes will come, but the failures are just as important, because they still tell you what doesn't work. It's still data. Just because it's not the data you want, it's still data. So that was how I worked through that, but not alone, with everybody else.
Well, and in the back of your mind too, EEEV is a pretty serious virus, and there's no cure. When it hits you pretty hard, and it goes right to your brain. What, in the big picture, if you do manage to come through with at least a few answers in this, what can you see that meaning?
Yeah, great question. Right now, fortunately, it affects horses more, luckily, but as we've seen with other New World alpha viruses like WEEV, VEV, it can be pretty detrimental to humans, especially with climate change. It's prolonging the presence of these mosquitoes and moving their range beyond endemic regions like Eastern US and Eastern Canada. So we might start seeing more prevalence of this. And when it can infect humans more, it can adapt better to humans. So it definitely is a worry that it can definitely get into humans more. And right now, it's not always a death sentence, but when it does get to your brain, it unfortunately pretty much is. So what I can see this research going is hopefully trying to find some answers so that one day we can have a vaccine or an antiviral, because to get there, somebody needs to do the work to understand the pathogen. So I'm hoping I can contribute to that, because I do really believe that even if it's not personally affecting me or people in Saskatchewan, that it's still really important to care about, because at least I got into this field because I want to do better. I want my research to help people, and I want to do better for the world. And so if I just care about myself and the people around me, that's not the world. That's not doing better for everybody. And that really wouldn't be what I stand for. So I think that this work can help if we unfortunately do get into the circumstances that this does become a big prevalent pathogen, as well as maybe even helping to encourage the mentality that we should care about everybody. We should want to help the world. Research is not just helping the West, it's helping everyone. I think that's really important.
Well, and in terms of your work, I hear that you're still going into the lab. You're still working on this. What's ahead? What's the fall been like for you?
Yeah, so I was definitely going a lot harder in September. Now I'm at midterms. I can't be in the lab as much, but I plan on getting back into it. But I was really fortunate in September to get to present at the PIN conference.
And PIN stands for?
Prairie Infection Immunity Network.
Oh, okay. And what did you present?
So I presented my summer research, which I was a little bit worried about because I just had this pile of contradictory information. So I was like, I don't really know what anyone's going to get out of this, but I just wanted to, present, learn how it's going to be. And I fortunately, and to my very big surprise, I actually won one of the best poster presentations.
Oh, congratulations.
Thank you so much.
Especially after the hard days this summer and the parts where you think, am I even right for this?
Exactly. Yeah. So it was a really fulfilling moment. And then also just the second place in the Biomed Project award. That was just another thing that I'm like, wow, okay, maybe I don't suck. Maybe I am okay at this. And so now I'm just looking forward to continuing on this project, hopefully finding my answers. I'm just a very curious person, so it's really driving me to keep going. And then I know in the summer, I'm going to be working back there. Next year, I'm going to be working on my honors project. And then after that, I plan on going into graduate studies and hopefully continuing this work.
Oh, viruses, look out.
Yeah, Eve's coming for you.
Thank you so much, Eve.
Yes, thank you so much for having me. I really appreciate this time.
Eve Simpson is working toward her honors degree in biochemistry, microbiology, and immunology. She was a second-place finisher at this fall's 2025 Undergraduate Research Showcase for her work on Eastern Equine Encephalitis Virus, EEEV. Her supervisor is Dr. Anil Kumar. Researchers Under the Scope is a presentation of the Office of the Vice Dean of Research at the U of S College of Medicine. We record and produce this podcast on Treaty 6 territory. We pay our respect to the First Nations and Métis ancestors of this place. We reaffirm our relationship with each other. And this is where we'd like to thank you for listening to the show and for being a part of science. If you made it this far, you are a true friend of research, so we'd love to see your star rating for the show. Let us know what you think in a review. I'm Jen Cannell. I'm your host. Thank you for sharing your ears with Researchers Under the Scope.